Okay, we've already talked about the different functions that we need to know. That's on the back side of our sheet. So what we're doing right now is we're just talking about how we can transform these functions. Now notice a stretch is whenever you have a number right in front of the equation. And just like the word stretch means to make taller or to stretch out, we're doing the same thing, except what it does is it actually makes functions look skinnier, taller and skinnier. And the bigger this number is, the more the function is stretched. So if we're looking at this problem, or not the problem, but we're going to fill out the chart. And what I want you to do first, though, is I want you to go ahead and draw a line on the chart. And we're going to call this parent functions. And that just means original. And instead of writing out functions, I'm going to write the word fun. And then new functions. But I'm just going to put fun. Okay, the parent, that's what they call the original function before you transform it. The new is after it's transformed. I'm not really sure why they call it the parent, except that's what you begin with, but you'll hear that, you'll hear it referred to like that in college and other places. So, if we were to look right here, you should know that an x squared is a parabola. So the parent function, and we're going to go ahead and just draw 4. So the parent is, what is the original function? What does it look like? So you told me parabola, so that means it starts at 0, 0, and it makes a u. Not a v, like absolute value, but a u. Okay, we're just going to make a rough sketch for the new function so it doesn't have to look, doesn't have to be perfect. So let's go ahead and just draw. And do 4 again on each side. And when I'm stretching, I still start at 0, 0, and just to let you know, this is called the vertex. My vertex is still at 0, 0, but instead of being wider, the stretch makes it skinnier. So that's just a rough sketch. Make sure it still looks like a U and not a V though. Okay, I tell you what, for the next few graphs, I want you to go ahead and just write down what it's going to look like. So let's just do our X and Y axes on all of these. So take a second and do that. If you need more time, you can pause the video. But I'm going to go ahead and move on. Alright, so let's go ahead and talk about the parent function for this. And if you look, what was the original function? What was absolute value? Because it has the bars. So that would start at 0, 0, and it's going to make a V. Now the horizontal shift to the right, this is why it confuses people. Because right actually means when you see a minus inside. Normally when we see minus, we think left. But for transformations, it's the opposite. So if it's a minus, it means go right. And this tells you how many to go right. So I'm going to go right 2. So what I do is I start at my vertex, and this is just like translations in 8th grade whenever you slid geometric shapes over. But I'm going to count for my vertex, and I'm going to count to the right 2, so 1, 2, and then I draw my shape there. But since I have this is only the parent function, and this is the new function, I'm going to draw it here. So if I was to start at 0, 0, I'd go to the right 2, put a dot, and there we go. Make sure it's a V. We're going to do the same thing for the horizontal shift to the left. This time it looks a little bit strange because we're like, well, what was that original function? Well, that's always just going to represent our line. So it's a linear line and has the point 0, 0 in it, just like all the rest of them. And this says to the left 3. Once again, notice left actually means a plus. And that always tricks people, but it's not going to trick you because you're a genius. Okay, so we're going to go to the left 3, so that means we would start at 0, 0 and count 1, 2, 3. And then we just draw it. Looks a little weird, sorry. Okay, let's do our vertical shift up. If you notice, what kind of function is this? should be the cube function. That's our fun little bitty s looking function. So it has the point 0, 0. And whenever we're drawing the cube function, I like to think of it as half a parabola, meaning this way points down, it's half of my u there, and then it's half of the u up here. Okay, so when you're drawing it, just make sure it's curvy. So this is like if the parabola was pointed down, this would be if a parabola is pointed up. So just make sure it has that kind of shape. Now, this means normal. Notice this number is not inside of the parentheses. It's just chilling on the outside. And plus 3 means move up 3. So I'm going to count from 0, 0, and I'm going to go up 3. So 1, 2, 3. And then I just draw my shape. Once again, a U pointing down with a U pointing up. And then a vertical shift down. You can easily tell that this is the square root function. And since it's the square root function, start at 0, 0, and it just kind of does that little fun thing. Okay, the rough sketch. Now shift down, so that means I'm going to start at 0, 0 and just count 2 down. 1, 2. And it's going to look something like that. Now these are not exactly correct. These are just rough sketches. The most important thing that I can show you all year long is the thing that's at the bottom of this page, all right? And what I'm actually going to do is I'm going to move this up. So hang on a second. Oop. Let's see if I can move it up. I don't think I can. So psych, not going to do that. We're going to look down here at the bottom. And I have this bubble just to remind you how important this is. Now, you will never find this in a math book. This is just Ms. Fruget's way of making it easier for you. And if you ever have a number that's in front of the parentheses, that is your stretch. So just go ahead and write the word stretch. When you have a number inside of your function, and normally it's going to be inside parentheses, that's going to tell you to either move left or right. If it's positive, we move left. So I'm going to put left at the top. If it's negative, we move right. And remember, it's going to be opposite of what you think. And then if it's on the outside, positive tells us to move up, and negative tells us to move down. So let me just highlight it for you real quick, just so you can see it a little bit easier. If it's positive on the inside of parentheses, that means I'm moving left. Just like if it's positive on the outside, I'm going to move up. If it's negative on the inside, that means I'm actually moving right. And if it's negative on the outside, that means I'm moving down. So if you need more time to copy this, go ahead and pause the video. If not, we're going to go ahead and we're going to move on to talk about what's on the next part of this worksheet. Okay, so moving on, I'm just going to remind you, let me just go ahead and write it again. So this is stretch. This tells me left. This tells me right. This tells me up. This tells me down. I'm going to highlight it one more time for you to see. So if I have a plus here, that means it's left. If I have a plus on the outside, it means it's up. If I have a minus down here, that means it's right. A minus outside means it's down. Okay, the first thing I want you to do is just describe in words what's happening to each one of these. So for number 1, you can tell that this had to be a parabola at the beginning because it had a squared. Now where is that number 2? Is the number 2 outside of the parentheses, inside of the parentheses, or just chilling outside of it? Well, it's inside. And if it's inside, what sign is there? A minus sign. So that means that I'm moving my parabola to the right because it's minus. And I'm not just moving it to the right, I'm moving it to the right. So your words would be move right 2. That's what you would tell me. Let's go ahead and move down to number 2. We're just going to write down the words. This, you can tell, should be a what kind of function? What would you say? Should be a cubed function. Okay, so let's look at these 2 numbers. I have 2 of them. I have this 3 and this 1. Is this number outside, inside, or chilling back there? It's outside, so that means it's stretched. So this cube function is going to look skinnier. But stretch by 3. And then what does this negative 1 mean? Is it outside, inside, or chilling? Well, it's chilling. And it's negative, so that means I go down 1. So when I'm graphing this function, I'm not just doing one thing to it. I'm actually doing two things. The first thing I'm doing is stretching. Then I take that new function and move that new function down by 1. Okay, and then number 3, this should be absolute value. There is no number outside, so it's not a stretch. What does the plus 1 mean? If you said 1 to the left, you are correct. So move left 1. This plus 3 right here, it's on the outside. So what do you think that means? If you said up 3, you are correct. Now here's what I do not want. For some odd reason, whenever I give this on a test, people will answer it. They will answer how did it transform by telling me the arithmetic. That is obviously not correct. So some people would say, Miss Fruge, I minus 2 here. Miss Fruge, I multiply by 3 and then I minus 1. No. That is so incorrect. You will never do that on a test. I can obviously see what arithmetic is taking place, but when I'm asking you what happened to the following functions, how were they transformed, I want to know, did it move right, down, did it move up or left, or was it stretched? That's what I want to know. All right, so now that that's out of the way, because I know none of you will make that mistake on your test, we're going to go ahead and we're going to graph these functions. Now, we're going to start off with our parent function, and I'm going to make the parent function be in blue. So let's go ahead and draw our x, y's, do for all 3. And I'm just going to make everything have 4 marks. So go ahead and take a second and do that on your paper. All right, we're going to go ahead and we're going to graph the original functions. So this is a square, so that means it's a parabola. It always starts at 0, 0. And just do a rough sketch. That's why it says rough. It's not going to be exactly correct. So the original would just be like a U. Now I'm going to change colors, but if you're writing in a pencil, instead of getting a different color, for the next shape you can just do dash or something. Okay? Now when it says move right 2, that means you start at your vertex and you're just going to count to the right 2. So 1, 2. So my new transform shape will be right here, and it's in red. Nothing else changes except I just pick it up and I move it. Okay, so let's look at number 2. This is a cubed function. And since it's a cubed function, that's our fun little bitty S looking thing. So put your vertex and then points down and then points up. Okay. All right, stretch by 3. Now this is a rough sketch. Remember, I'm saying rough sketch. Stretch by 3 means it's going to be skinnier, right? So it's not going to be as wide as this. Now what I'm actually going to do is I'm going to do this in 3 different steps. You don't have to. In fact, for number 3, we're going to do just 1 step. But sometimes the EOC likes to have this as a graph, then this as a graph, and then the final answer as a graph. So that's how we're going to do this one. But if I'm stretching this by 3, that means I'm making this one skinnier. And you could just connect that with little bitty dashed lines. And then I'm going to take that graph and I'm going to move my stretch graph down 1. And if you're doing a pencil, instead of doing dashed lines, how about you do dotted lines to connect your last one? So all I do is I take this shape and I'm just pushing it down 1. So it needs to look about as skinny as you made the other one. So that's your 3 shapes. Now you can either do it this way, have all 3 of them, or you can just have your parent and then your new one. And that's how we're going to do number 3. So your parent graph, if you notice, is going to be the absolute value. So 0, 0, make a V. And we're going to the left one and up 3, because I'm not going to do separate graphs like I did for this one. So to the left one means I would start at my vertex, go left 1, and then from this spot up 3. 1, 2, 3. And then just graph. So once again, these are rough sketches. They're not exact. And also you need to keep in mind that you can either graph just the parent and then the new function, or you can do it step by step. Here's my parent, then this was when I stretched it, then this is when I stretched it and I moved it down one. So it's up to you how you want to write it. All right, that should be it. If you have any questions, ask Kayla.